Welcome to Creata classes. In this lecture, we will do the complete summary and the revision of medians. You can use this lecture for just going before the exam or one day before the exam for doing the quick summary of the medians. It will include all the formulas and the fundamental related to medians. Go to the download section and download the PDF which is having all the fundamentals and the formulas related to medians. Let's begin with the lecture. Median is a line segment that joins the vertex with the midpoint of the opposite side. This is the midpoint. So the median divides the opposite sides into two equal portions. We can say 1:1 ratio. Triangle is having three vertex and the three sides, so it can have total three medians. And these three medians are starting from the vertex and they are meeting the midpoint of the opposite side. For this triangle, AD, BE and CF are the three medians. The three medians of a triangle intersect at a common point. Let's say the intersection point of the three median as G. The point G is known as the centroid of the triangle. The point of intersection of three median is known as centroid of the triangle. Basically, the centroid is the center of gravity of the triangle. Further, this centroid divides the median into the ratio of 2:1. The point G divides the median into the ratio of 2:1. That is, AG is to GD for this triangle will be 2:1. For example, if we take AD as 9 cm, then AG will be 6 cm and GD will be 3 cm. The ratio will be 6:3, that is 2:1. Got it? Similarly, the ratio of BG is to GF will be 2:1 and the ratio of CG is to GE will be 2:1. A common mistake, the ratio 2:1 is generally interchanged as 1:2. This is the common mistake. The remembering technique is that the number 2 or the numeric 2 will lies with the vertex. Here 2 is with the vertex A and here 2 is with the vertex B and here 2 is with the vertex C. This is the remembering technique to avoid any confusion. Moving further, we will start with the fundamental. That is, the ratio of area of triangles with same altitudes will be equal to the ratio of their bases. For example, in this figure, if we say the ratio of BD is to DC is A is to B, BD is A and DC is B, then the ratio of area of triangle ABD is to the ratio of area of triangle ADC will also be equal to A is to B. The ratio of area of both of these triangles will be equal to ratio of their bases if their altitude or the height are same. For both of this triangle, the altitude or the height is same. So we can say that ratio of area of both of this triangle is equal to their bases. This is a concept. If we apply this concept to the medians start with the vertex and joins the midpoint of the opposite side. Means the median divides the opposite side into the ratio of 1:1. So we can say ratio of area of both of this triangle will be equal to 1:1. Why? Because ratio of their bases is 1:1. In other words, we can say median divide the area of triangle into two equal parts. Similarly, these medians will also divide the area of triangle into two equal parts. Why? Because they are meeting with the midpoint of the opposite side and they are dividing the opposite side into the ratio of 1:1. If you observe, the three medians have divided the area of triangle into 6 equal parts. Area of all these small triangles will be equal to 1/6 of the area of complete triangle. These are 6 triangles, so each will be having 1/6 of the area of triangle ABC, that is the complete triangle. In other words, we can say the medians divide the area of triangle into 6 equal parts. Got it? Moving further, the next concept is that area of triangle is equal to 4/3 times area of triangle formed by the median. If we take a triangle ABC with median as A, B and C, A, B and C are the three medians for this triangle. If we take out these three medians from this triangle, can we form a triangle from these three medians? This triangle with median A, B and C is known as the triangle formed by the medians. And area of this complete triangle ABC is equal to 4/3 times the area of the triangle formed by the median. Okay, this is an important concept, will be used in solving questions related to area of the triangle and area of the median. Moving further, now we will see the relation between the sides of the triangle and the medians of the triangle. The first relation is that AB plus AC is greater than twice of AD. Here AD is the median and AB and AC are the two sides of the triangle. As per this relation, if we add two sides, say AB and AC, then the addition of these two sides is always greater than twice the median which is between those two sides. Okay, got the concept? Similarly, if we talk about the median CE, then we can say AC plus BC is greater than twice of CE. Okay, we have taken the median between these two sides. Similarly, we can say AB plus BC is greater than twice of BF. We have applied the same fundamental in the three medians. This is important relation, that is addition of two sides is greater than twice of the median which is between those two sides. Please note it down. Further, based on this relation, we can derive a relation, that is AB plus BC plus AC is greater than AD plus BF plus CE. That is, the sum of three sides of the triangle is greater than sum of medians of the triangle. Here AB, BC and AC are the three sides and AD, BF and CE are the three medians of this triangle. As per this fundamental, the sum of the three sides is always greater than the sum of three medians of this triangle. Okay, remember this. Moving further to our next relations, we will study two relations together. These two relations are 4 times the sum of medians of the triangle is greater than 3 times the sum of the sides of the triangle. The next relation is 3 times the sum of sides of the triangle is greater than 2 times the sum of medians of the triangle. These are two important relations. The common mistake that the student do is that they interchange 4 with 3 and 2 with 3. So the remembering technique is that the numeric 3 will always come with the sides of the triangle. Just remember that the numeric 3 will come with the sides of the triangle. Triangle, the three angles or the three sides. So the number 3 will come with the sides of the triangle. And number 4 and number 2 will come with the medians. For the first relation, 4 is greater than 3. So you can remember the 4 times the sum of medians is greater than the 3 times the sum of the sides of the triangle. Further, in the next relation, the numeric 3 is greater than 2. So you can remember 3 times the sum of the sides of the triangle is greater than 2 times the sum of median of the triangle. Got it? These are the 4 relations which is having greater than or less than symbol. Now we will see the relation between the medians and the sides of the triangle which is having equal signs, and these relations will be used in solving the problems related to the sides and the medians. And the first relation is known as the Apollonius theorem. This is very important theorem, will be used in a wide applications. As per this theorem, a square plus b square is equal to twice of c by 2 whole square plus ad square. Here a, b and c are the three sides of the triangle. A square plus b square, that is the sum of square of two sides of the triangle. Here we have taken the side a and side b, is equal to twice of c by 2 whole square. C is the third side. Plus ad square. Ad is the median between the side a and b. Here we have taken the median which is between the side a and b. This is the Apollonius theorem. Based on this Apollonius theorem, we can derive the formula, that is 4 times the sum of square of medians is equal to 3 times the sum of square of the sides of the triangle. We are not going into the proof of this theorem or the formula, we are just doing the summary. So we are just listing down the formulas and the fundamentals. Okay, got it? So these all are the relations between the sides of the triangle and the medians of the triangle. Moving further, now we will take the special case related to the medians. The first case that we will take is the medians in a right angle triangle. Let's take a right angle triangle ABC which is having a right angle at angle B. Here AC is the hypotenuse for this triangle. Let's take a median BD. BD is a median, so D will be the midpoint of the side AC or the hypotenuse AC. As per the property, median to the hypotenuse, that is the median BD, is equal to half of the hypotenuse. As per this property, BD is equal to half of AC. If we take any medians in a right angle triangle which is connecting with the hypotenuse, that median is equal to half of hypotenuse. So we can say BD is equal to half of AC, which is further equal to CD, which is equal to AD. So we can also say AD is equal to BD is equal to CD. Here A, B and C are the 3 points which are equidistant from the point D. So if we take D as a center, can we draw a circle with 3 points as A, B and C? The point A, B and C are equidistant from the point D. So we can form a circle with center as D. For the circle, AD, BD and CD will be the radius. This circle is a circumcircle, that is the circle touching the 3 vertex of the triangle. Just a small fundamental. Okay, this is the first property. Now let's move to the second property of a medians in a right angle triangle. Let's take a right angle triangle ABC with 2 medians as CN and AM. For this property, the formula is 5 by 4 AC square is equal to AM square plus CN square. In other words, we can also say 5 by 4 hypotenuse square, that is AC square, is equal to sum of square of the 2 medians, that is AM square plus CN square. So this is also important relation in a right angle triangle with the medians. Okay, these are the two properties. Okay, these are the two fundamentals or the properties of a medians in a right angle triangle. Please note that these two formulas or the fundamental will be applicable only and only for a right angle triangle. We cannot apply this formula in an equilateral triangle or any other type of triangle. Moving next, the next is also a special case, that is when 2 medians are perpendicular to each other. For that, let's take a triangle ABC with 2 medians as CF and BE. And these 2 medians, that is CF and BE, are perpendicular to each other. Okay, this is the case, the 2 medians are perpendicular to each other. Here CF and BE both are perpendicular to each other, means this angle is 90 degree. For this case, the applicable formula is AB square plus AC square is 5 times BC square. Here AB, AC and BC are the 3 sides of the triangle. For this fundamental, only the 3 sides are coming in the formula. Note that median is not in the formula. Okay, you can say this is also a remembering technique. Only the 3 sides are coming in the formula. That is AB square plus AC square is equal to 5 times BC square. This is applicable only and only when the 2 medians in a triangle are perpendicular to each other. Okay, got it? So this is all about the medians. So that's it for the summary or the revision of the medians. You can go to the download section and download the complete list of formulas and the fundamentals. Okay, PDF is in the download section. So that's it for this lecture. Thank you very much for being with Creata classes. Best of luck.